Do you remember we had spoken about this question the last time, and I said today I would just quickly finish off 6.3 and 6.4 with you. So I just want to do that, if that's okay with everybody, because I don't like leaving things unfinished. Is that all right if I just finish these two questions, or would you prefer I start on functions? What's the general consensus? How do you feel, Matrix? Want me to finish or just move on? Do it. Okay. All right. Okay. All right, yeah, because these are two sort of more difficult questions. So I do really want to do them with you. Okay, so let's just jump straight in and get that done. Okay, so if you recall from last time, we were given the graph f of x equals tan 2x and the graph g of x equals 1 plus sine 2x. Okay, for where x is greater than or equal to negative 135 and up to 135. And we had answered questions 6.1 and 6.2. And then I almost said the bell went. We're not at school. But the lesson ended and we didn't manage to do 6.3 and 6.4. Okay, so if we have a look at question 6.3, they have given us determine the values of x for which, and then they are multiplying tan 2x with minus 1 minus 2 sine x is smaller than or equal to 0. Okay, now this is a bit of a nasty one because this is actually a quadratic inequality. So, you know, like in paper 1, in question 1, they ask you to solve a quadratic inequality. So, for example, let's say they give us x squared minus 6x plus 8 is smaller than or equal to 0. And they ask us to solve for x. It's exactly the same idea. So our next step in the pink would be to factorize. In this case, we would get minus 2 and minus 4. And then we would find our critical values. So that would be where x was 2 or where x was 4. And we call them critical values because that's the value at which y changes from either being negative to positive or positive to negative. And what your teachers would have taught you to do here is to draw a graph. So it's a parabola. We need our x-axis, our smaller numbers on the left, our bigger numbers on the right. And now we go back and we have a look. Here, x squared minus 6x plus 8 is smaller than or equal to 0. Okay, so that's going to be over here where y is negative, smaller than 0. Okay, so it's the same idea with this particular question, except they've made it a lot more difficult because now they've introduced it into trig. And there is something else here that we need to contend with. I don't know if you realized, but in this, oh man, and I've made not made a mistake, but I've made an omission here. Sorry, let me just correct that before I move on. Sorry, I've just seen it now. Sorry, it's minus 1 minus sine. Oh, come now, pen. Sine 2x. Okay, so it's minus 1 minus sine 2x is the question. So the additional thing that they have done here in this bracket, can you see in this bracket here, this is the one I'm talking about, can you see that they have changed the signs compared to what they gave us in the beginning? So the 1 is negative and the sine 2x is negative. So what we could do here is we can take the negative out of this second bracket. And what happens when we divide by the negative on both sides of our inequality? What happens to the sign of our inequality? Can anyone remember? Yeah, it changes. It changes. It flips around. Okay, so in other words, what we would have is tan 2x times 1 plus sine 2x. And instead of it being smaller than or equal to 0, it's now going to be greater than or equal to 0. Okay, so essentially what they've done here is they've asked us a question like this. They're really asking us for which values of x is f of x times g of x, because this is f of x over here. This is f of x. So for which values of x is f of x times g of x greater than or equal to 0? That's really what they're asking us. Whoever would have thought, but that's what it means. Okay, so if they want us to multiply the y values together and get a positive outcome or 0, it either means that both graphs need to be negative at the same time, or both graphs have to be positive at the same time, their y values. So if we go and have a look, and they said between negative 135 and 0, so that's between this vertical line over here and our y-axis. So if we start at negative 135, the pink graph is positive, the green graph is negative, until we get to negative 90. Between negative 90 and 0, between negative 90 and negative 45, both graphs are going to be positive. After negative 45, the graph in green is negative and this one is positive. So that's not going to satisfy our condition. So it's going to be between 90 and minus 45. We can include 90, we cannot include negative 45. So the answer to this question is going to be where x is a number that is greater than or equal to negative 90, but smaller than negative 45. Does that make sense to everybody? Lesedi, you're welcome to unmute and speak.
Hi, ma'am.
Hi, Lesedi, how are you?
I'm good, thanks. Yourself?
I'm fine, thank you.
Ma'am, my question is, why don't we include negative 45 because it's at 0?
Okay, so that is because of the asymptote.
Okay, thank you, ma'am.
Okay, so that's why we're not including the negative 45. All right, no problem. Okay. All right, so this is a definitely a lot more difficult sort of question. It would have been better for us to obviously do it when we were doing the others, but I just wanted to go through that with you. All right, question 6.4 is something that I've seen asked a couple of times. They've told us here that graph G is transformed. Now remember, G is our sine curve. By shifting the y-axis 45 degrees to the right, what happens to the graph of G if the axes move 45 degrees to the right? Okay, so there's still questions coming through for the previous question. Why can't it be 0 and 45? Because, Jamie, if you look in the interval from minus 45 to 0, the pink graph is above the x-axis. The green graph is below. So the y values on the green graph are negative. The y values on the pink graph are positive. A positive times a negative is not a positive. So it doesn't satisfy what we're looking for over here. Okay, we want negative times negative or positive times positive. We don't want negative times positive. Does that make sense, Jamie? I hope so. Okay, Jamie's not answering. I'm hoping that makes sense to you, Jamie. All right, so back to question 6.4. They've moved the y-axis 45 degrees to the right, the y-axis. Because, Jamie, they told us that our interval, look here, our interval is here. It's only between negative 135 and 0. So we can't look to anything to the right of the y-axis. Okay, that's why. If they hadn't given us that restriction, then we could have. If they said between negative 135 and positive 135, then we could have, but we can't. Cool. All right. Back to question 6.4. Right, so they've moved the y-axis 45 degrees to the right-hand side. What would that mean for the graph of G? If the axes move 45 degrees to the right, what would happen to the graph of G? Or what would it appear has happened to the graph of G? Any idea? Anyone got any idea? What would it seem has happened to G if we shifted the y-axis 45 degrees to the right? So we can see it here. I'll highlight it in pink for you. Here's the y-axis. Well, actually, let's use a different color. Let's use yellow. Here's the y-axis. If it's not there anymore and it's now here, y-axis is now here. It's moved 45 degrees to the right. What would be the effect on graph G? What would it seem has happened to G? Shame everyone's too scared to say anything in case it's wrong. Okay, so let's just see. There's some things come through. Not sure, Pinga. Okay, that's why I think it's worthwhile us discussing this. Okay. Exactly. I hope I'm pronouncing your name correctly. Is it Zanandi? I hope I've said that right. Okay. So Katleho, what I'm saying is I'm reading the question. If the y-axis has been shifted 45 degrees to the right, what do you think has happened to the graph? Okay, and the suggestion there, who said it, shifted to the left, Zanandi, is correct. It would seem as though the graph has shifted to the left if the axes moved to the right. So if we take a graph and we shift it 45 degrees to the left-hand side, then we would need to add 45 degrees, or the value inside the bracket would be plus 45. So in other words, what I'm saying is this, okay, P of X is going to be 1 plus sine 2x plus 45, because the graph has been shifted, or it appears as though the graph has been shifted 45 degrees to the left. If we move the axes, or the y-axis, 45 degrees to the right-hand side. Okay, that's what would happen. Okay, difficult question. I have seen that before. What they then want us also to do in this particular question is then use compound angle formulae to rewrite it in a different way. But I'm not going to worry about doing that now. It's already 6:15. I want to get into the functions. Okay, so anyway, there we go. We finished it off. These were more difficult questions, but as I said, I wanted to do these with you. If you're not 100% sure, you can always come back and watch the video again. But let me just ask, are there any last questions before I move on? No? We're all good? All right, let's jump into functions. Okay, so here we go. We have been given the graphs of g of x equals a over x plus p plus q, and f of x equals x squared plus 4x minus 5. Yes, Katlego, what's your question?
Ma'am, just to confirm, did you say that the sine graph would move to 45 degrees to the left or to the right?
Okay, so in this particular question, what they were saying has happened is that it looks, well, the y-axis has been shifted 45 degrees to the right. That means the graph would have been shifted 45 degrees to the left. So if you move the axis to the right, the effect on the graph is to move it to the left-hand side. Because by moving the y-axis to the right, the graph is shifted to the left. Okay, and that's why if the graph is shifted to the left, why it would be sine 2x plus 45. Okay, Katlego? All right, let's go back here. So what sort of graph are they implying g of x is? If they give us a over x plus p plus q, what are they implying it is? What sort of function? It's a hyperbola. Exactly. Good. Well done. And f of x is a parabola, a quadratic function, and they've given us the equation of f of x. The equations of the asymptotes of g are x equals -2, so we can see that is the vertical asymptote, and y equals -9, that is the horizontal asymptote. G cuts the x-axis at A, so this point over here, which has the coordinates -8/3 and 0. The turning point of F lies on the intersection of the asymptotes. So in other words, we know that the coordinates at the turning point of F have to be at -2 and -9. Okay, let's go and have a look at the questions. The other thing that we can do quickly, I like to do this when I have more than one function sketched, is I like to highlight my formula and I like to highlight my graph just to make it pop out a little bit more for me. And then let's do this one in blue. And there is our parabola. Okay. I wonder if we can move these questions. Let's get rid of me because I don't need to be here. Let's see if we put these questions next to it, if it just makes life a little bit easier for us. Okay, so the first thing that they want us to do in 5.1 is write down the range of f. Write down the range of f. Can anybody suggest an answer to 5.1 for us? The range of f. How would we do that? It's 1 mark, the range of f. Okay, Lesedi is suggesting something. Mbali, a different answer. Jude, same answer as Mbali. So let me ask a question. Let's just see, there's a couple more suggestions coming in. Okay. Sure, Lesedi, that gets a lot of people. And Kanyiso, yours is the most correct answer that I've seen so far. Okay, so, all right, this is why it's a good question to ask. All right, so iPhone, your range, sorry, I'm calling you iPhone, but I don't know what your name is, unfortunately. When we talk about the range, it's not our set of X values, it's our set of Y values. So this particular function is a smiley face parabola. It has a minimum and the minimum value is -9. So our range can be written in one of two ways. Either y is greater than or equal to -9, or if we want to write it using interval notation, we can say y is an element of, and then -9 is our smallest number and positive infinity is our biggest. So that would be our other alternative there. We are including -9. Okay, so in this question on range, we would include the -9 because it is an output of the function. Okay. Yes. Yes, it is. Okay, so when we don't include things, like in that previous question, I didn't include the -45. There was a question on that. Why? Because that was an asymptote. And the tan graph cannot equal -45. So I excluded the -45 in this case. When they ask you a question about range, okay, the y value, a y value of this parabola can be -9. It's the minimum. So we can include -9. Yes, absolutely, Zwanaka. There's a number of ways in which you can find the coordinates at the turning point. So using the derivative and making it equal to 0 is one of them. Absolutely. Okay. In this case, we don't need to work out the coordinates at the turning point because they were given to us. All right. The next thing that they want us to do is to calculate the x and y intercepts of f. That should be quick and easy. You guys do that and you can DM me or Yolanda the answers, please. So the x and y intercepts of f. If you want, I can move it over a little bit. X and y intercepts of f, please, matrix. You guys are going to do this yourselves. Let's have a look. Oh gosh, lots of ones. Okay, so Chelsea. Cool. Mbali. Lovely Mbali. Good Nkaniso. Good Lihlu. Yes, Jude. Perfect. Good Xiao. Yes, Lorato. Good. Okay, so a lot of you sending through correct answers there. That's perfect. Okay, so for the x-intercepts, we're going to make y equal to 0. I'm just working behind you guys here so that the answers are on screen if anybody wants to come back and watch. And then, of course, we would have to factorize. And we would get the answers, you guys. Sorry, that must be plus, and that must be minus. So x is equal to -5. Sorry, it's not written very well. X is equal to -5. Or x is equal to 1. And we can see that. We can see that the graph, this is where the 1 would be, and that's where the -5 would be. The graph has definitely been shifted over to the left-hand side. Okay, and then quite right, that over there would be the y-intercept. Okay, so our y-intercept is going to be at 0 and -5. Good. One little point that I do want to make here, please, when you're making your graph equal to 0, don't omit the 0 on this line. At matric level, often we get an accuracy for our factors, so don't leave it off the equals 0, even if you've written it above. Don't be lazy, rather just write it. Okay, excellent. Let's move on to the next thing. We've done 5.1 and 5.2. Now in question 5.3, let's just scooch over so we can see the question properly. Determine the values of m for which f of x equals m has two unequal negative roots. So first of all, what does f of x equals m mean? Can anybody explain that to me? What are we talking about here? F of x equals m. So remember, f of x is our parabola. So f of x equals m. What do they mean here? Okay, so in this case, Pinga, you don't have to work for the discriminant. Don't have to work with the discriminant because it's only out of 2. So they don't expect a whole lot of algebra. But yes, you're right. You're absolutely correct to link it to nature of roots. That's very good. But we can do this graphically rather than algebraically. Okay, so that's good. Okay. Okay. In this case, I understand why you're saying that, Sydney. Okay. They are not implying that M is gradient in this case, but one could be forgiven for thinking that they were, but M is not gradient. Aha, Pinga, good, well done. So it's a simultaneous solution. This is y, f of x is y, and m is y. So what they are implying here is that there is a simultaneous solution between the graph of f of x and a straight horizontal line, okay, because it's y equals m. That's what they mean by this. Does that make sense to everybody? This is something that you should have seen before. Okay, so it's a simultaneous solution between f of x and m. F of x is y, m is also y. So if y equals m, it is a horizontal line that can be moved up or down. Let's just make it a little bit longer. Okay, so what they want here are two unequal negative roots. Okay, so if I take my pink line, okay, which is a little bit skew, and I put it over here, what sort of roots do I have? I've put it at the turning point. What sort of roots do I have? If the pink line is sitting at the turning point, what sort of roots do I have, Matrix? Okay, so a few different answers coming through here. First of all, I have real roots, okay, because it's touching once. If I was to take that pink line and move it down, are the pink line and the blue parabola, are they touching each other at the moment? No. So I would say that the pink line and the parabola have non-real roots at the moment. If I take the pink line and I move it up so that it's sitting at the turning point, then I would say that the pink line and the parabola have equal roots. Okay, real equal roots. If I move the pink line up, now I've got real roots. Okay, so in other words, if I want the roots to be unequal, I cannot have the pink line at the turning point. It has to be above that. Okay, the roots that are now are unequal, the roots, what they're talking about when they say roots, is the points at where these two intersect each other. So now there are two unequal roots. Okay, two unequal x values where they are equal to each other. Does that make sense to everybody? Okay, because it would be this value of x over there and that value of x over there. But they not only do they want the roots to be unequal, they also want them to be negative. Yes, correct, Pinga. Okay, because they're talking about the roots. The roots are the x values, okay, not the y values. Okay. So if we have a look at the moment, here's your y-axis. Let me highlight it for you in a different color. I'm going to make it green. Okay, here's the y-axis. Now I'm highlighting the y-axis because x is negative to the left of the y-axis. All right, so I can move this pink line up to the point where it now cuts the y-axis as well, where the parabola is going through. Okay, now one of my roots is no longer negative because it's going to be equal to 0 on the y-axis. If I keep moving my pink line up, I will have one positive root and one negative root. Can everybody see that? So over here, this root here will be a positive root. This root here will be a negative root. So I cannot go higher than that point over there, where the two intersect each other on the y-axis. Does that make sense to everybody? Because that is where one root will be 0. I also cannot move my line lower than that. Because if it was to be lower than this, then it means that the roots would be non-real. So I have to be somewhere between here and here. Does that make sense to everybody? You guys are very quiet this evening.
Yeah, everyone is still, I think, taking it in since they are writing tomorrow.
Okay. Are you sure this is making sense to you guys? You must have seen this at school before. Your teachers must have shown you. Okay, we're all good, ma'am. Okay. Lesedi, thank you for that. You've made me feel a lot better because sometimes I'm just worried that I'm talking and talking and you guys are sitting there thinking, what on earth is this woman going on about? But that does make me feel better. All right. So we've got between, let's just draw another pink line and I'll move it up. So we will have two unequal roots between the two pink lines. Oh, it's okay, Pinga, that's fine. All right. So here, the pink line at the top is the line y equals -5. The pink line at the bottom is the line y equals -9. Okay, so that means that the value of m has to be a number that is bigger than -9, but smaller than -5. Yes, essentially, Jude, they are, because they're saying f of x equals m, y equals m. Okay, so that m value is a y value. Yes, Lesedi, your hand is up.
Hi, ma'am.
Hi, Lesedi.
Ma'am, why are we using y values when they said we must determine the values of x?
They didn't say we must determine the values of x. They said we must determine the values of m. So let me just put the question there. Can you see it on the screen now? Lesedi. That's fine. No wonder you were confused. Okay, so they said determine the values of m. Okay, so f of x equals m, so it is a y value. Okay, so they're asking us for which values of y when our roots, our x values are unequal and negative. Then in question 5.4, now they're saying to us for which values of x. Okay, all right, so we're all happy with that. M has to be a number greater than -9, but smaller than -5. Okay, now they say determine for which values of x in 5.4.1 f is increasing. What do you guys think? In 5.4.1, for which values of x is f an increasing function? Remember, f is your parabola. That's it, Chelsea. Good job. Okay, when x is greater than -2. Lovely. And now we are not including the -2. Although, strictly speaking, they could still give you the mark if they say strictly increasing, but we should not include the turning point. Okay, because then we know the graph is not increasing at the turning point. Okay, so when x is equal to 2, the gradient is 0. So it's not actually increasing. We mean a positive gradient. Good. Well done, Chelsea and Jude, for your answers. Now, determine for which values of x in 5.4.2, g of x is smaller than or equal to 0. So now they're asking about the graph G. They're asking about the hyperbola. For which values of x is it negative? Okay, so maybe what I must do here is I'll highlight the x-axis as well. There's the x-axis. The x and y-axes are highlighted in green. So g of x is y. So for which values of x is y negative? So y is negative when the graph is below the x-axis. Okay, so Pinga, I'm just looking at your answer. Yes. And then here. Good, Pinga. Yes. All right. So Pinga sent me an answer. Let's see what some of the other people are sending through. Good, Pinga. Yes, that's the same answer as Lesedi. That's the same answer as Pinga. There's just one more bit that we need to consider. Yes, Lihlu. Okay, good, Lesedi. Okay, so 5.4.2. Good, Sihawo. That's nice. Well done. So a lot of the answers coming through, they're looking at that point that I've just drawn in orange there, that x-intercept. Okay, so when x is a number that is smaller than or equal to -8/3. So good. So where x is smaller than or equal to -8/3, y will be negative. Absolutely, it will be below the y-axis. And then there is it depends how you want to write it. Hang on a second. Jude, you can include the infinity symbol when you are using interval notation. So that's the one with the brackets. But if you're writing with set builder notation like I did in question 5.4.2, then it's not necessary to include the infinity symbol. So the alternative way of writing this part of the answer would be where x is an element from, and then we would have negative infinity up to -8/3, and then we would have to have a square bracket. Okay. All right. But this is not the whole answer. All right, because there is another portion of the graph where this is happening. So can everybody see that when x is a number that is bigger than -2, y will also be negative? Okay, in fact, it'll never get bigger than -9. That's its asymptote. So we would say here, or where x is greater than -2, but I cannot include the -2 because it cannot be equal to -2. Okay, that is your asymptote. So what you would do here, Jude, is you would use the union symbol for or, and then you would start with the -2 with a round bracket, and then it would go up to positive infinity. Okay, so either you would write your answer like this using set builder notation, or you can write your answer like that using interval notation. Okay. All right, next question. They want us to determine the equation of G. So let's just go back up. They want the equation of G. So in other words, they want us to fill in the values of A and P and Q. So what do we know straight away? We've got the asymptotes. Good, lovely. Good. We've got the horizontal asymptote and we've got the vertical asymptote. So yes. So then, Andy, should I do this? Would this be correct? Would that be correct for the P part? Is that correct, what I've written there? Lesejo, good. We also have a point which we could use to determine A. All right, so this needs to be a plus because the graph has been shifted 2 units to the left. Okay, and then my Q value, oops, I nearly wrote plus there. My Q value is -9. Okay, there we go. Good, Zanandi, well done. All right, and now as Pinga said, we've got another point, A, which we can go and sub in to work out, or the coordinate A, where we can go and work out what the small a is equal to. All right, so in other words, we've got g of x is equal to a over x plus 2 minus 9. And now we want to sub in point A, which is -8/3 and 0. So we're going to let y be equal to 0. We're going to let x be equal to -8/3. And now we need to solve for A. All right, so the -8/3 plus 2 leaves us with a strange value underneath here, but it doesn't matter. It's -2/3 and then the -9. What I'm going to do is I'm going to take the -9 over to the other side and make it +9. And now I'm going to, oopsie, why am I writing -1? Now what I'm going to do is cross multiply. So the -2/3, I'm going to cross multiply this and this. Okay, and remember 9 means 9/1. Okay, so when I multiply 9 with -2/3, I end up with -6. And that would be the value of A. It's okay, Zedalia, it's fine. Okay, remember Q is your horizontal asymptote. Your horizontal asymptote, if they've shifted it below the x-axis, then it would be a negative. Okay. All right, so we're almost there. That means that the equation of g of x, it is the graph -6 over x plus 2 minus 9. So in other words, because A is negative, the graph has to be drawn in the second and fourth quadrants. It's been shifted 2 units to the left because it's x plus 2 and 9 units down. Shame, Pinga. To be honest with you, questions 5.3, 5.6 would be considered a hard question. What do I have over here? That would be, I can also show you what I did with the standard class, Pinga. You can maybe take a photo of that. Maybe that will be helpful to you. But the beginning questions are always easier, and it's the end questions that are a little bit harder. Okay, so let's see what you do with this. Pinga is looking forward to a challenge. Let's see what you do with this one, Pinga. Okay, and everybody else. Okay, so we've got the equation of G. Now they tell us the graph of G is translated to obtain graph P. Describe the transformation from G to P if the axes of symmetry of P are y equals minus x minus 10 and y equals x plus 2. So this is something to think about. So the hyperbola has been translated, translated. And they use the word translated, not just transformed, but translated on purpose. Very important. Describe the transformation from G to P if the axes of symmetry of P are this. Okay, so my question to you then, Pinga, I used to have a friend who always used to say, why do you answer every question with a question? So my question to you, Pinga, when you say, should we find the axis of symmetry of the original? Do you need to? If you, okay, better question. What point on the graph do the axes of symmetry always go through? That's a better question for me to ask you, Pinga. No, we don't have to, Tsechofatsu, you're quite right. So what point on the function, on the Cartesian plane, do your axes of symmetry always go through? What about the asymptotes? Pinga? The? Aha. Good. Okay, so your axes of symmetry will always go through the point of intersection of your asymptotes. Okay, so now how would you work out where or the x coordinate of that new point of intersection? How would you solve for that? So your axes of symmetry always go through the point of intersection of your asymptotes. Based on the information they've given you, how would you calculate the x coordinate at the new point of intersection of your asymptotes? Aha, Jude, well done. Good job. Okay, do it, Jude. Okay, so Pinga, your axis of symmetry is always going to take one of two forms. Okay, so it's either going to be y equals minus x plus k, k being the y-intercept, or it's going to be y equals x plus k. So the gradient will always either be -1 or +1. So that's why you can see here. So this is the axis of symmetry with a negative gradient. And the other line that they give us is the axis of symmetry with a positive gradient. Okay, so Jude has asked me a question. I can see he's got it. I'm just wondering about the other 42 of you. What would you do? Okay, I got that answer, but negative. No, Pinga, unfortunately not. There's a little bit more to it than that. Remember, your axes of symmetry will cross over one another at that new point of intersection of the asymptotes. How are you going to work out what the x coordinate is at that new point? Do you want me to show you, or do you want to think about it? We were sort of just running out of. There we go. It's okay, Jude. Fine. There we go. Zanandi's put it. There we go. Well done, guys. Okay, make the equations equal to one. Yes, you do. Okay, because they're going to cross over one another at that new point of intersection. Do you see how this is a knowledge question and an understanding question? If you know that about the axes of symmetry, then you'll know to equate these two. Well done, everybody. That's really nice. I'm so pleased you're sending through those suggestions. Okay, so we would take minus x minus 10 and make it equal to x plus 2 to get the new x coordinate at that point of intersection. So that would give us minus x is equal to 2 plus 10. So we'd get minus 2x equals 12. So x would be equal to -6. -6. So they're asking us to describe the transformation. Oh, I'm so glad, Katleho. That really makes me so pleased. I'm so glad that you find this helpful. That's the nicest thing anyone can ever say to me. Thank you. So glad it's helping you guys. That makes me feel really good. Okay, so Katleho, Pinga, Sihawu, Lesedi, all the others. Okay, we are now sitting at -6 for our point of intersection. We were at -2. So we've gone from x equals -2 to x equals -6. So that means that we have to have translated how many units to the left? It must be translated 4. Good. Well done, guys. 4 units to the left. Okay. It may also have been shifted up or down. So what we would need to do is then work that out as well. Okay, so we've got 4 units to the left. Where were we sitting? We were sitting at -9. So let's just work out what y is equal to. So y is equal to x plus, so if y is equal to x plus 2, then y would be equal to -6 plus 2, which would be -4. So as far as y is concerned, we've gone from y equals -9 to y equals -4. So that would have been translated how many units? 5 units up. Beautiful in Kanyiso. Okay, so Pinga, how do we know? Okay, so in other words, if you've gone from -2 to -6, so you're talking about in terms of x, so that's got 4 units smaller. That's why I've said 4 units to the left. Okay, because that vertical line has gone from -2 to -6. Okay. Does that make sense, Pinga? 5 units up. Okay. So there we go. 4 units to the left and 5 units up. Correct. So good, Pinga. I'm so glad. Iola, so ma'am, with X, is it left or right? And then with Y, up or down? Correct. Correct. So if you subtract from X, like in this case over here, we were moving the asymptote to the left. Okay. All right. If you want, just very quickly, what I can do, Pinga, I know you said you were looking for other questions. I've just done this one with a standard class. I know I've kind of written all over it. If you want to, you are welcome to, tell you what, Pinga, let's just do this. Just give me 1 second, Pinga. I'm just moving this back here. There's another question you guys can try. If you want to screenshot this, Pinga, this will give you a bit of a challenge. Let me just move. It's me. Let me just move this up. If you want to challenge Pinga, you can screenshot this question. Question 6.3.2 will be difficult. And then if you want to, you can also screenshot the next question, or you guys can just, what class are you? You are the standard class. So this is the class where we do things that are more difficult. Okay, Tsehofatso. This is the challenge class. This is the more difficult questions are the ones that I do with you guys. And then if you want to, here is another. Let me just maybe move it over there. Sorry, I'm just trying to. If you want to try this one as well, there's the equation. And then there are the questions underneath. It also involves a little bit of inverses as well. Yeah. Yeah, it's a nice maximum length question. Yeah, it was a bit fast today. Sorry. I can't believe how quickly our time runs out. Lesedi?
Hi, ma'am.
Hi, Lesedi.
Ma'am, you missed my question in the chat,
Oh,
and I was
I'm
asking,
so sorry.
and I was asking you to explain why we equated the two equations again.
Okay, no problem. All right. So what you need to understand about the reason why I equated these two together is because your axes of symmetry always intersect one another at the place where the asymptotes intersect one another. They both go through that point. Okay, Lesedi. So your axis of symmetry with a positive gradient will go through this point. Your axis of symmetry with a negative gradient will go through this point. So if you want to work out the x coordinate of where this point is, you would now make those two equal to each other and solve for x. Okay, because it is the point of intersection of two straight lines. Okay. All right, good. I can move to the, sorry, a couple of you just asked me, can I move to the second graph? There we go. So that was this question over here. So you can try this one, Penga. Hopefully 6.3.2 will give you a challenge, especially since Q is a point on that inverse function and T is a point on the other function. And then I do, but I don't have the memos on screen available at the moment. Tsegofatso.